Hello class, Dr. Bans here. So let's see about these two questions. So let's find their Z transforms, okay, and then their ROC, all right. Okay, so let's start with the first one, which is A. So to be able to solve these questions, okay, we have to remind ourselves of our previous class where we found the Z transforms for the following. Okay, where we found the Z transform for A n u a exponent n into what? U of n. We found its Z transform. Okay, and we got what? Z over Z minus what? E. Okay, and then the ROC was such that mod Z was greater than what? A. Okay, mod Z was greater than A. So here is what? Z transform. Okay, and we also did the same thing. Okay, for what? Minus a exponent n into u of what? Minus n minus what? 1, okay? Where we got the Z transform, to be what? Minus Z over what? Minus Z over a minus what? Z, okay? And then this particular thing we have here is the same thing as what? Is the same thing as Z over what? Z minus what? A. Okay, and then this one, the ROC was mod what? Z. Okay, mod Z was less than what? A. Okay, so here, why do I say that this one is greater? Is the same thing as this one? It's simple. Okay, it's simple because you know that minus Z over what? A minus Z. If I should multiply through, okay, if I should multiply through by negative 1, I'm going to get what? Z over what? Over minus A plus what? Z, okay, which is equal to Z over what? Z minus what? A. All right, so it's the same thing as this one. Okay, so moving forward, we're going to solve these two questions from knowledge from these ones. Okay, knowledge from these ones. Okay, especially we're going to use the first one. Okay, all right, so now let's go straight into A. Okay, so into A, we are given we are actually given what? A, we are given x of what? N to be equals to what? X of n to be equals to 2 over 3 exponent n into u of what? N plus minus 1 over 2 exponent n into u of what? N. Okay, so now here, what is going to happen is that we find them what? Separately. What you can see is that whenever you have 2 over 3 exponent what? N into u of what? N is the same thing as a exponent what? N into u of what? N. So that means that the Fourier transform of this one will be equals to the Fourier transform of this one. In this case, which will be equals to what? Which will be equals to Z over what? Z minus A. And what is the A here? Is what? 2 over 3. So minus 2 over what? 3. And then our ROC, okay? And then our ROC will actually be what? Mod of what? Z. Mod Z is what? Greater than what? 2 over what? 3. Okay? So basically, that is what we're going to get over there. Okay? That's what we're going to get over there. And then from there, we can go on to the second one. Okay, so for the second one, we're going to get minus 1 over 2. Okay, we're going to get minus 1 over 2. Okay, into n exponent u of n, which is actually going to be what? See, this one is the same thing. Okay, this thing we have here is the same thing as what? A exponent n into u of what? N is the same thing. So the same Z transform will work for it. Okay, so the same Z transform will work for it. So here it will be what? Z over what? Z, because here is minus. Okay, it will be plus 1 over what? 2 plus 1 over 2. And then our ROC is going to be what? Mod Z which is greater than what? Minus 1 over what? 2. Minus 1 over 2. But because here it's minus, because it's minus 1 over 2, we have to take the modulus of it, okay, so that it becomes this. Okay, so now we can just write the overall Z transform, okay. So now that means that for the x of n, let's say Z transform of x of what? N, okay, which is basically equals to Z transform of what? Of 2 over what? 3, okay, 2 over 3 exponent n into u of n, okay, plus 1 over what? 2 into what? N into u of what? N, okay. This particular Z transform, okay, is going to be equals to what? It's going to be equals to Z over what? Z over Z minus 2 over 3, okay, plus Z over what? Z plus 1 over what? 1 over 2, okay, and then I'm going to have ROCs, okay. I'm going to have ROCs, 2 ROCs, okay. So the 2 ROCs are going to be mod Z is greater than 2 over 3, and the second one will be what? Mod Z is greater than what? Mod minus 1 over what? 2, okay. And what will be the final ROC? Okay, the final ROC will be such that the final ROC is going to be what? 2 over 3, okay. So let me write here final ROC. Final ROC will be such that mod Z, okay, is greater than 2 over 3. Okay, so now let me plot it, then you're going to see why I'm saying that it's going to be what? 2 over 3. Okay, so now plotting it, this is what we're going to have, okay. So now this is real of Z, and then here is imaginary of Z, and here is 0. So let's say 2 over 3 and 1 over 3, which is smaller. Okay, 1 over 3, 2 over 3 and 1 over 2, which is smaller. 1 over 2 is smaller. Okay, 1 over 2 is smaller. So let me plot the circle 1 over 2 first, because it's smaller. Okay, so here mod Z, okay, is equals to 1 over what? 2. It's negative 1 over 2, okay. So I'll take the modulus of it, okay. And then the other one, okay, the other one is what? 2 over 3. That's a bigger circle. So let me say that okay, so here mod Z is equals to 2 over 3. Okay, so the 1 over 2, okay, here, what is is such that it is Z is greater than, okay, Z is greater than what? So let me go to the 1 over 2 first. Z is greater than what? 1 over 2. If it's greater, then it will be outside, okay, so that means that this place outside for the 1 over 2. Okay, now let me go to the 2 over 3. Z is what? Greater than what? 2 over 3. If it's greater, then it has to be what? Outside. So I'll give that one also another direction. So that one is respect to this one. Okay, so here it's like this. So now, where do I know my answer? I know my answer from the what? Here, let me add one here like this. I know my answer from the intersection. And where are they intersecting? Actually, you can see that they are intersecting at where I have the 2 over 3. Okay, they are intersecting at where I have the 2 over 3. That's why I say that my final ROC is what? Greater than 2 over what? 3. Okay, greater than 2 over 3. Because you can see that it is not intersecting here. They are rather intersecting here. So that is why it's 2 over 3. Okay, so that is for the A. Okay, now let's go to the B. please, for the A, we have to do this one, the pole zero location. So let's do the pole zero location for the A. Okay, let's do the pole zero location for the A. So we are not yet done with the A. We don't write the A. Pole zero location. Okay, pole zero location. So now here, x of z is equals to, we got z over z minus 2 over what? 3. Okay, plus z over what? Z over z plus 2, 1 over what? 2. Okay, plus 1 over 2. Okay, so this one, if we should actually multiply 2, okay, then we're going to have z plus 1 over 2, okay, plus, okay, sorry, it's plus, okay, plus z minus 2 over what? 3, okay, all over, okay, so all over what? All over z minus 2 over 3 into what? Into z plus 1 over what? 2, okay. So this is what we're going to have here. Please, here is plus. Please note it is plus. Okay. So when we do that, then we're going to have x of z, okay, to be equals to, okay, so we're going to have x of z to be equals to this one. If you should do the summation here, okay, I'll get what? 2z, okay, then this plus this one also. Okay, this plus this one also. This is negative, this is what? Positive. So I'll get what? 2z into, I'll get 2z, okay, 2z into here minus, if you subtract this and this, you get 1 minus what? 6, okay, 1 minus 6, okay. And then there's another z here. If I bring it up, okay, it's going to be what? Z over this, okay. Then here I'll have z plus z, okay, plus 1 over 2 plus 1 over what? 2, okay, and z into what? Z into minus 2 over what? 3, all right. Now what I have to do is that poles and is that equating the denominator to 0. Zeros are equating the numerator to what? To 0. I hope you know why I'm getting this particular z. Okay, why am I getting this particular z? Okay, you see that here, if I bring this guy up, okay, there will be z here. And here, if I bring this guy what? Up, okay, there will be a z here. Okay, there will be a z here. Okay, so now these two z's are common. That is what I bring it what? Over here. Okay, and then you have this guy's what? Over here. Okay, so now zeros are going to be z into what? 2z minus 16 is equals to what? 0. So now you're going to have z is equals to 0, and you're going to have z is equals to what? Here, positive 16 over what? Positive 16 over 2, okay, over 2, all right. So basically, what are you going to have over there? Okay, so I'm just going to have, sorry, here is 1 over 6. So it's 1 over 6, okay, it's 1 over 6, sorry, 1 over 6, okay. So basically, 1 over 6 will go here to be positive, okay, and then this one will go and actually also divide it, okay. So I'm going to get, z is going to be equals to 1 over 2 there, okay. Then let me see about the zeros. About the poles. Okay, now let me see about the poles. Okay, so for the poles, what I'm going to have is it's going to be so I'm going to have z plus 1 over 2, and then z minus 2 over 3 equals to what? 0. So I'm going to have z is equals to what? Minus 1 over 2, minus 1 over 2, and I'm going to have z is equals to what? 2 over what? 3. Okay, so these are what I'm going to have for the poles into zeros. So now, knowing this one, what I will do again is to just draw my poles zero plot. Okay, poles zero plot. So now here, I'm going to have it this way. Okay, so this is a z plane. So this is imaginary z. And this one is real what? Z. Okay, so now the poles, so let me see my poles. Here, let me see the zeros. I have 0 and then half. So this is how you represent this one by a small circle, the zeros by a small circle. So here, z is equals to 0 and then half. Okay, so here, okay, a small circle. Z is equals to what? Half. Okay, and then the zeros, what do I have? 2 over 3. So here you represent the poles like this. Okay, so here z is equals to 2 over 3 and minus 1 over 2. So here z is equals to what? Minus 1 over 2. Okay, so this is how you can do the poles zero plot for this particular question. Now let's go to the second aspect of this question, which is B. So in B, we are given z x of n to be equals to 3z over z. Sorry, this is not what we're given over there. Okay, so basically, sorry, this is what we're given. X of what? N is equals to 3 out 5 over what? 7. Okay, n into u of what? N. Okay, plus 2 out minus 1 over what? 3 into what? N into u of what? N. Okay, so this is what we are given. Now, given this one, now what? Taking z transform of both sides. Okay, taking z transform of both sides, what am I going to have? I'll have what? I'll have x of z. Okay, I'm going to have x of z. I'm going to have x of z. Taking Laplace transform of both of this side. Okay, then I'm going to have x of what? Z is equals to 3 what? Z. Okay, this one is just like the a exponent n into u of n. So I'll get what? 3z, this 3 and z. Okay, over what? Z minus 5 over what? 7. Okay, z over 5 over 7. Okay, plus this plus what? 2z, this 2 and z. Okay, over what? Z plus 1 over what? 3. Okay, over 1 over 3. And what will be my ROC? So now my ROC is going to be what? It's going to be 2. Z is what? Greater than. Okay, so now Z is going to be what? Greater than 5 over what? 7. And then the second one here. Okay, Z is going to be what? Also greater than what? Minus 1 over what? Over 3. Okay, but because this is negative, I'll take the modulus of it. Okay, so because whenever you are drawing a circle, you don't draw a circle with a negative radius. The radius has to be what? Positive. So you take the modulus of it. Okay, so now here my final ROC. My final ROC is going to, which is greater? 5 over 7 is greater. So it's going to be such that Z greater than what? Greater than 5 over what? 7. Okay, 5 over 7. Now that's how my ROC is going to be like. Now what I can do is I can just plot my ROC. Okay, so now if I should plot my ROC, what I'm going to have is it's going to be like this. Okay, here I'm going to have this one. Okay, so what am I going to have? I'm going to have 1 over 3 as a smaller circle. Okay, and then it's greater, Z is greater than 1 over 3, so it's going to be outside. Okay, it's going to be outside. Okay, so here mod Z greater than mod minus 1 over what? 3. Okay, all right. Then I'll draw the bigger circle, which is what? 5 over 7. So 5 over 7 is like this. Okay, before, this place is what? Imaginary of what? Z. Okay, this place is imaginary of what? Z. And then here is what? The real of what? Z. Okay, so here, this bigger circle, okay, is also, is like this, is mod Z is greater than 5 over what? 7. So if it's greater, then I'll have to shade what? Outside. Okay, I have to shade outside. Okay, so like this, like this, like this. Okay, so like this. Okay, so this one, if I should continue, this one, if I should continue. So you see that the intersection is what? Outside, outside of the circle with radius 5 over what? 7. Okay, all right. So basically, here, Z, mod Z is the radius is equals to negative 1 over 3. Here, mod Z is what? Equals to what? 5 over 7 for the radius. Okay, and then where I have shaded is what? What is what? Where I have shaded is called Z is greater than 5 over 7. But for the circle itself, for the radius of the circle, Z is equals to what? 5 over 7. Okay, but where I have shaded, Z is greater than 5 over 7. And for this one also, the 1 over 3, the circle itself, Z is equals to 1 over what? Minus 1 over 3. Okay, or mod Z is equals to what? Mod negative 1 over 3. Okay, and where I have shaded, Z is greater than what? 1 over 3. Okay, so basically that's how you can do this one. Okay, now let's find the what? The poles and zeros. Now let's find the poles and zeros for the B aspect. So poles and what? Poles and what? Zeros. Okay, poles and zeros for where? For the B aspect. Okay, so for the B aspect, we got x of what? Z is equals to what? 3z over what? Z minus 5 over what? 7 plus what? 2z over what? Z plus 1 over what? 3. Okay, that's what we got. Okay, so now if we have this one, then what we can actually get is that we can have Z out. Okay, I can have Z out 3. Okay, I can have Z out. Okay, 3 into what? 3 into here. Okay, Z plus 1 over 3. Okay, yeah, that's what I can have. And then I can have plus 2. I can have Z out. Okay, Z out. Okay, 2 into what? 2 into Z minus 5 over what? 7. Okay, okay, all over what? All over Z minus 5 over what? 7 into what? Z plus 1 over what? 3. Okay, so if you should do your simplification here, then what you're going to get is that you're going to have x of what? Z is equals to Z out, okay, 3Z plus 1, okay, plus 2Z, okay, minus 10 over what? 7. Okay, so that is what you get over what? Z minus 5 over what? 7 into what? Z plus 1 over what? 3. Okay, so that is what you will get there. Okay, so if you should do your simplification further, then you're going to have Z out. Okay, sorry, Z out. Okay, you're going to get 5Z minus what? Here you're going to have let me check well. Okay, so this one and this one. Okay, if you subtract this one and this one, okay, then you're going to get what? Minus 3 over what? 7. All right, minus 3 over 7. Okay, then it's going to be over what? Z minus 5 over what? 7 into what? Z plus 1 over what? 3. Okay, so now your zeros, okay, you're going to have z is equals to 0 for this part, okay, and then you're going to have z is equals to 3 over what? 35 for this part, okay, for this part, okay, because your zeros are such that z into what? 5 minus what? 7, 5z, sorry, 5z, okay, 5z, sorry, let me cancel it, okay, so your zeros are actually such that, okay, z into what? 5z minus what? 3 over what? 7 is equals to what? 0. So if you equate this one, you get what? 0. If you equate this part, you get what? 3 over 5. Okay, now your poles. So now your poles are actually such that you're going to have what? Z minus what? 5 over what? 7, and then z plus 1 over what? 3 equals what? 0. So if you equate this part to 0, then you're going to get z is equals to 5 over what? 7. And if you equate this part to also 0, you get z is equals to what? Minus 1 over what? 3. Okay, so now if you should plot this one on your z plane, this is what you were supposed to get. Okay, so here is real of what? Z. And here is what? Imaginary of what? Z. Okay, so now let me plot my zeros. So my zeros, I'll get here z is equals to what? 0. And then I'll get another thing again, 3 over what? 35. That is very small. So that one also here, you plot the zeros with dots. Okay, so here z is equals to 3 over what? 35. Okay, then I come to what? My poles. I come to my poles. So what are my poles? 5 over 7. So 5 over 7. Let's say this is 5 over what? 7. Okay, so 5z is equals to 5 over what? 7. And here minus 1 over 3. So minus what? 1 over 3. Z is equals to minus 1 over 3. 1 over 3. So you see the way I'm representing the poles by this one, the way I'm representing the zeros by small circle, small circle. Okay, so now basically you can also do your ROC here, region of convergence here. Z is equals to what? Positive 5 over 7. So my circle must pass through what? 5 over 7. So I can say that this is it. Okay, and it's what? The ROC was such that, I mean the final ROC, okay, is such that mod Z is greater than what? 5 over what? 7. If it's greater than what? Then outside. Okay. Okay, outside. All right, so that brings us to the end of this particular question. All right, see you in the next class. Thank you so much.